So now we want to use that difference quotient. We're finding f of x plus h minus f of x over h. So here's my f of x. So I will have f of x plus h will be 1/2 of x plus h. And then remember, it's minus f of x, so minus the regular function 1/2 of x, and it's all over h. If I multiply that out, I'll have 1/2 x plus 1/2 h minus 1/2 x all over h. Combining like terms, 1/2 x minus 1/2 x, that's gone. So I have 1/2 h over h, and the h's cancel out. It's just 1/2. Here's another function to find the difference quotient for. F of x plus h. Well, here's my x. So it starts at -2 times x plus h plus 3. That's my f of x plus h. Now I'm going to subtract f of x. So I need to subtract the whole function f of x, -2x plus 3. So I'm subtracting the whole thing. And then I put that all over h. Getting rid of my parentheses, I'll have -2x minus 2h plus 3. Negative times a negative, positive. 2x minus 3 all over h. Combining like terms, -2x and positive 2x, they're gone. -2h, I only have one. -2h. And 3 minus 3, oh, they're gone, over h equals -2. So the difference quotient for this function is just -2. Let's go on to another, x squared minus x plus 3. Okay, remember, f of x plus h minus f of x, so f of x plus h minus f of x. So putting x plus h in place of x squared, I will have x plus h squared minus x plus h, the parentheses are important, plus 3. And now I'm going to subtract all, the entire function, parentheses, x squared minus x plus 3, all over h. Well, x plus h squared. Square the first term, x squared. Multiply them together, h times x and double it will be 2hx. Square the last term, h squared. Removing parentheses, it'll be -h, -x minus h, and then plus 3. Removing this parentheses, it'll be negative x squared plus x plus 3. And of course, this is all over h. Combine like terms. X squared, -x squared, they're gone. 2hx, only have one of those. 2hx. X squareds, only have one of those. H squareds, only have one of those. X, -x, positive x, they'll be gone. -h, only have one of those. And 3, oops, this should have been a -3. 3 minus 3, so those are gone, all over h. From the numerator, I can factor out an h. I'll have h times 2x plus an h minus a 1 all over h. These h's can go out. And my difference quotient is 2x plus h minus 1. In case you were thinking all difference quotients came down to just a number. Not true. Okay, here's another problem to find the difference quotient for. Now, remember, well, the difference quotient in this case will be g of x plus h minus g of x all over h. So we'll have negative 2 of the square root of x plus h, and then it'll be minus negative 2 square roots of x all over h. Bringing that down here, we'll have negative 2 square roots of x plus h plus 2 square roots of x all over h. Negative times negative is positive. Now, difference quotients are a unique thing, and instead of rationalizing the denominator, which this already is, we actually have to rationalize the numerator. To do that, I'm going to start by factoring a negative 2 out. So I'll have negative 2 square root of x plus h, and then this will be minus the square root of x all over h. To rationalize it, I'm going to do very similar to using the conjugate. So I'm going to take the square root of x plus h. I'll take it times plus the square root of x. This will give me a difference of squares thing and take care of middle terms will be gone. So do that for both the numerator and the denominator. When I do that, I'll end up with negative 2 times square root of x plus h times the square root of x plus h will be just x plus h. Negative times the positive will be a negative. Square root of x times the square root of x will be x all over h times the square root of x plus h plus the square root of x. I can simplify the numerator. I'll have negative 2h. X minus x, those will be gone. And the denominator will be my h over the square root of x times the square root of x plus h times the square root of x. Oh, these h's can cancel out. And my difference quotient will be negative 2 over the square root of x plus h plus the square root of x. That will be my solution.